Okay, so let's take up the question of how long it's going to take to get to the steady state. So that's where we left off last time. Hopefully you understand mechanically the pieces in here. So here I put time on this axis. In effect, what I did was in Excel, I just set it up exactly the way we've set it up, except for I put it for years as we go along. So you're able to back this out, and the textbook, again, can walk you through that. And if you want to know how to do that, let me know. I'll be happy to walk through that with you. So this is output across time. Now, it doesn't quite look like our output-capital relationship, and that's okay. There's no reason they need to look the same. Does this look like the historical record? Not so much, right? You think about what we saw in the historical record, which is that hockey stick. Let's zoom out. So this is 100 years. Maybe we zoom out. There's 300 years, still growing. Maybe we zoom out a little bit more, 500 years. It turns out we're still growing. It's a little hard to see, but if you look at it, we are still growing. Maybe we go out to 1,000 years. Whoops, there's 500. We can go out to 1,000 years or more. It's going to look pretty much the same. Still have positive growth. But again, because of those diminishing marginal returns, we're going to have less value generated by each additional unit of capital, and say we start to the left of our steady state, which plausibly is where we start, given that we know historically where that human being started. By the way, that's implicitly what I'm doing. If I was starting out and to the right of our steady state, we would be contracting. The economic growth would be contracting. So the question is, have we reached there in 500 years? And the answer is no. So let me put this, instead of it being levels, just the level of output, let me put it in terms of growth rates. So here we have the Solow growth rate, and I went out to 1,000 years. Now that looks pretty much like it's zero, but it still is actually above zero. Let's zoom out a little bit more. So now this is our percent change every year. So maybe 500 years, there's 300 years, there's 100 years. Now you'll see a blue line and a red line in here. The blue line is 10%, which is the growth rate that the Chinese economy has maintained for roughly 30 years. Now in the last few years it's slowed, which shouldn't be surprising for us at all, by the way. As the Chinese economy catches up, catching up growth may be kind of hard. But does that fit what we see in our model here? 30 years of growth. At 30 years of growth, what should the growth rate in the Chinese economy be according to our Solow model? Right around 2%, 2.3%. That's nowhere near. The Chinese growth rate is much, much higher than that. So that tells us we're probably missing something. Now let's look at the United States. The United States has been able to maintain an average growth rate of somewhere between 2.5%, between 2 and 3% typically over the last 200 years. So it turns out that the United States should have in fact started out growing really rapidly and then also declined. The growth rate should have declined even though growth was continuing to expand. And we should have hit our long-term growth rate and continued to fall 30 years after we started growing, which clearly is not actually what we have seen. So when I do the math, the Chinese economy should have started growing really, really rapidly, and then within 5 years dropped below and continued to drop below 10%, whereas the United States should have grown very, very rapidly and then eventually within 31 years hit our long-term growth rate and continued to fall. So, does our Solow model fit the historical record? Does it fit the contemporary record? The answer is no, it doesn't. Although it can help explain catching up growth, why countries would start out growing rapidly and then slow down, which is what we're seeing in China, and it's also what we saw in Germany and Japan. It can't explain cutting-edge growth yet. So we probably need to tweak it, but it can explain catching up growth, and so we've made some progress. Now, let's go back to our assumptions. So we need something that will fit the historical record. And we've looked at just machines. And hopefully you understand that the implications from our model are that machines on their own are not going to get us there. Our assumptions were that we were holding technical knowledge constant, labor constant, human capital constant. We can actually also add in there that we were holding the savings rate constant, and that this is different than supply, by the way. You'll notice I'm using letters in multiple ways. I'll try not to do that too often. But here the savings rate is constant, and we are also assuming that all savings makes it into investment. So let's start one by one relaxing these to see when we can get to the historical record. So let's start by relaxing the savings rate. And so this picture shows us what happens if the savings rate increases and all savings makes it into investment. In other words, our investment line will shift up. Our output capital line will stay exactly the same. Our depreciation line will stay exactly the same. And then the question is, what happens to growth? And the answer there depends on where we were. If we were to the left of 100, growth will be higher than it otherwise would have been. If we were at 225, our growth rate will be higher than it would have been otherwise. If we were out at 400, our output growth would have been higher than it would have been before. Wait, it actually turns out that it doesn't matter where we are in here. With a higher investment rate, our output will be higher than it would have been before, and our growth rate will be higher than it would have been before. Say we were at 300. Before, we would have had a negative growth rate. Now we're going to have a positive growth rate. 300 units of capital, I mean. So our growth rate has gone up. Say we were all the way out at 500. Before, we were going to have a large negative growth in both capital and output, and now we're going to have a smaller negative growth. So again, we've had a positive impact on growth rates. So we can also then look at this as to what happens if we take two countries, one with a low level of savings and another with a high level of savings, and we start them off at a very low level of capital. Going from a low level of savings and thus a low level of investment will cause an increase in our time output relationship. But let me go ahead and put that in terms of growth rates, right? Now here in this case, I've increased the savings rate from 30% to 50%. This, by the way, doesn't mean that we're better off. It's possible that by now we are saving so much that our consumption has gone down, even in the long run, and we're actually worse off. It's unclear. So again, we should understand that there's a difference between growth rates and well-being. Hopefully that resonates. And again, our Sniff test would tell us that countries with higher investment rates have higher GDP per capita. Does this picture pass our Sniff test? Does it fit what we would expect? Go ahead and think about that. Look at this for a while. Once it pauses after I stop talking here, I will stop here and I will pick this up and we will continue on here shortly. So go ahead and maybe commit yourself to an answer. Does this fit with what our picture would just tell us? Countries have a higher per capita GDP from this picture if they have a higher investment rate. Does that fit our model, or does that go against our model?